All right, so this one talks about how Jesse's Can Company makes a cylindrical cans and needs help computing the amount of material that is required to create each can based on its volume and radius. So let's take this really slow and really understand what this problem is asking, because the first part says write an algebraic expression. So we're going to have an expression for the surface area of the can. So I, at the end, want to know what is the surface area of this can, which includes the top and the bottom, in terms of the radius and volume. So be sure to define all of the variables you might need to solve this problem before you start. Recall that the volume of a cylinder is pi r 2h. So I think it's r squared is what it should be. So when I'm walking through this problem, right, the surface area means I have this can. I'm going to do a really crude drawing here where there's one circle for the top, one circle for the bottom, and then if I were to snip on the outside, I'd really get kind of like this rectangle shape for the outside here. So to find the surface area, I have to find the area of each of these pieces. Area of the circles, they are going to be the same. It's just pi r squared and then pi r squared. And then my rectangle here, really I need to find the circumference of the circle, which will be this side length here, which would be 2 pi r, because that's how we find the circumference of a circle. And then this side here, in orange here, that is our height. So we'd multiply 2 pi r times the height here. And again, that's the circumference of that circle, which gives us the side, and then the height, which gives us the other side. So now that's my kind of expression here, but I'm going to combine some things because I have pi r squared plus pi r squared, which is 2 pi r squared plus 2 pi r times h. And I'm going to go ahead and now, again, reading the question, make sure I understand that it says, like, I need it in terms of radius and volume. And so in this case here, what I notice is that volume being pi r squared times h, I'm going to solve this for h and then plug it into my equation over here. So in this one here, I'm going to say that h is equal to volume over pi r squared. And then I am going to go ahead and plug that in to h here. So I got 2 pi r squared plus 2 pi r times the volume over pi r squared. I'm going to simplify that a little bit because my pi's cancel here, one of my r's cancel, and so my surface area is 2 pi r squared plus 2 times the volume over the radius. So here's my expression that represents surface area, with it being volume and radius as my variables. Got rid of height just by using the volume formula. So now I have 2 pi r squared plus 2v over r. It asks me, hey, if I have a volume of 34 cubic centimeters and a radius of 4 centimeters, how much material? Now, because we've done all this hard work for A, we can just plug in these values to give me my final answer here. So I'm going to rewrite this 2 pi, my radius is 4, my volume is 34, my radius is 4 again. I plug all that into a calculator, I get 32 pi plus 17. And then again, I'm going to go ahead and round my answer to the nearest thousandths, and I get 117.531. And it's saying how much material do I need? So that would be centimeters squared.